Hello everybody, welcome to the Law of Cosines Proof video. What I have written out here is just the law of cosines, the three equations, and what we're going to go through in this video is how to arrive at these equations. So let's begin first by drawing a triangle in the coordinate plane. So set up a coordinate plane for yourself. We got our x-axis, our y-axis, of course. And here's where we're going to start to put our triangle. We're going to put our angle A here at the origin. And then over here on the right, we're going to put angle B. And it's going to make a acute, so we're going to put angle C up here somewhere, so that when we connect these dots, we get an acute angle for an oblique triangle. The next thing we're going to do in this coordinate plane is label what each coordinate would be. I mean, over here at A, we know that that would be 0, 0. Up here at C, some arbitrary C value we don't know, so we just call it x, y. Over here, keep in mind, opposite the angle C is always the side length, C. So that means this length horizontally is C. So what I can say for B then is, instead of writing x, I can actually write C, because that represents the horizontal length here, C. And then the y value here is 0. Right, I'm still on the x-axis, so the y value is 0. Let's label the other sides as well. Opposite angle A, I have side A. Opposite angle B, I have side B. And as we've been doing in these videos, it's important to identify H as well. So draw your line straight down from angle C. Make sure you're noting that's the right angle. And normally we would call this H, but because we're in the coordinate plane, remember we call vertical lengths in the coordinate plane Y. And then in this right triangle that I've created, this horizontal length from point A to the Y line is x, right? I don't know what x value it is. I'm just going to call it x, some value x. And so from this triangle we've created, we can identify a few things. The first being cosine of A. It's fair to say that cosine of angle A, given this right triangle right here, is adjacent x over over hypotenuse B. X over B. It's also fair to say that sine of A is opposite y over hypotenuse B. Now from both of these equations, what I can do is solve for x and for y. I can say that x is equal to b cosine A, and y is equal to b sine A. And those are going to be helpful for us when we start to think about how to describe the length A. The length A is more than just A. It can actually be expressed using the distance formula, because A is the distance between two coordinates, x, y, and c, 0. So that's what we're going to fill in. I'm going to write that in as the step I'm taking, distance formula. And I can say that A is actually square root. Right, that's what the distance formula goes. It goes square root, and then it goes parentheses x2 minus x1 squared plus y2 minus y1 squared. Now what I'm going to start doing here is I want to lift this radical off of the right side of the equation. So in order to do that, I can square both sides. And I get a squared equals x minus c squared plus, notice in here, subtracting 0 isn't going to do anything, so I really just have y squared. And from here, what I can start to fill in are my equations for x and for y, right? I have things that I should substitute in for x and for y, so let's go ahead and do that next. A squared equals b cosine a minus c, and I'm going to FOIL that out because it's a binomial squared. Plus, I'm not going to say y squared, I'm going to say b sine a squared. I'm going to start writing a little bit farther out here to the left now. So a squared equals, when I FOIL this out, the first term I get is b squared cosine squared a. The next two terms would both be negative bc cosine a. So if I have two of those, I have negative 2 bc cosine a. And then lastly, I'd be ending with plus c squared. And then don't forget, you also have b sine a squared. So that's going to become b squared sine squared a. Remember, the argument doesn't get squared, just the trig function gets squared. So it's just sine squared, not big A squared. And from here, what we can do, I'm actually going to get a separate sheet of paper now, is write the terms that both have a b squared in front together. So we can say a squared equals b squared cosine squared a plus b squared sine squared a minus 2bc cosine a plus c squared. I'm going to write that further out here to the left. A squared, now notice in these first two terms, they both have a b squared. So we're going to factor that out. And we're going to get cosine squared a plus sine squared a minus 2bc cosine a plus c squared. What's really cool about this now is that we've arrived at the value of 1. This is an important property for us to remember. Keep in mind, whenever I have a cosine squared plus a sine squared, this is equal to 1, right? That's a Pythagorean identity. And so, if I have 1 times b squared, I have just b squared. So I say a squared equals b squared plus c squared minus 2bc cosine a. And if writing c and then cosine is a little trippy for you, you can separate it up with a little multiplication symbol. That's what I've been doing. And what we've done is we've just arrived at the first law of cosine, right? The first equation. Right there. Pretty cool stuff. Now we can arrive at the rest of them if we go back to that triangle, but we label it just a little bit differently. So let's start that with our next one. So same coordinate plane. But this time what we're going to do is we're going to put angle B at the origin. Angle C is still at the top, and angle A is out here to the right. We connect our dots, we make our triangle. Over here we're solving for side B this time. Remember, down the middle we still have y, we still have x. This side length is still c. This side length is going to be a now. And we still have the coordinates over here. A is the coordinate c0, c is the coordinate x, y. And the trig functions we're going to talk about now are kind of like last time. Last time we used this angle over here on the left. Oh, pardon me, now you can see that. We used this angle over here on the left. It was A last time, now it's B. And we found the cosine and the sine of this. So that's how we're going to start again. we're going to say cosine of B and sine of B. Cosine of B, adjacent x over hypotenuse A. Sine of B, opposite y over hypotenuse A. And again, we can solve for x and for y. And again, we can solve for this side, for side length B, if we use the distance formula once again. So down here, again, distance formula, we could say B equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We can square both sides to get rid of the radical. And we can also fill in for x again. So a cosine B minus c, a cosine B minus c, plus y squared plus a sine B squared. I take care of this expansion here, and I get the first term, a squared cosine squared B minus 2 of AC cosine B. And then I end with plus c squared for that binomial. And then over here I have the last term, a squared sine squared B. Again, very similar steps as before. I'm going to group the two terms that both have an a squared. B squared equals a squared cosine squared B plus a squared sine squared B. And then I have my minus 2ac cosine, that's a capital letter B, my bad, cosine B plus c squared. And just like last time, I'm going to use some factoring. And I'm going to say a squared, oh, pardon me, I was looking at the wrong thing. B squared equals a squared gets factored out of those first two terms. And then I have sine squared plus cosine squared. Oh my goodness, I keep making mistakes. Sine squared B plus cosine squared B. There we go. A little rough there. But I factored out my a squared. And then I have still my minus 2 AC cosine B plus c squared. And just like before, I have this Pythagorean identity inside the parentheses, which becomes the number 1. And so I'm left with a squared by itself plus c squared minus 2ac cosine B. And we've arrived at our second law of cosines. And let's do the last one, which again can be achieved if you take that same triangle, but you label it just a little bit differently. This time, we're going to put C at the origin, right? We've put every other angle at the origin so far. So this time, we're going to put C at the origin. We're going to make B the angle on top, and we're going to put A over here at the right. Draw out that triangle. A is now the coordinate C0. B is the coordinate XY. We have the height Y, that length X, side B at the bottom, side C on the side, side A on that side. Okay, everything's all labeled. And just like before, we start at this angle over here on the left and we identify the sine and the cosine of it. So sine of that C, sine of that C, opposite y over hypotenuse A, and cosine of that angle adjacent x over hypotenuse A. I solve for both of those equations and I get y equals a sine C and x equals a cosine C. Once again, the next step is finding the distance of C by using the distance formula. I'm going to start that below here with some more room. C equals the square root of, again, it's set up exactly the same way every time. X minus, oh, pardon me, I made a mistake here. This coordinate is no longer the letter C. This coordinate is the letter B because the side length is now represented by the letter B, not C. So pardon me, that was a mistake. Make sure that's changed. Okay. And then that affects my formula down here, right? X2 minus X1. X1 is now B. So X minus B is what I should have in here. Plus Y2 minus Y1 squared. And again, I can lift that radical off if I square both sides. I can fill in for my X and for my Y. A cosine C minus B, that's going to be FOILed out. And plus A sine C squared. So C squared, my first term here, A squared cosine squared C minus 2AB cosine C plus B squared. Over here I get A squared sine squared C. I group the two terms that have the common A squared. And again, the next step after that will be factoring, just as it has been. So I write everything else out here. Take out that A squared. And once again, we arrive at the Pythagorean identity inside those parentheses. Which becomes 1, and I have finally arrived at the last law of cosines. A squared by itself, because that becomes 1, plus B squared minus 2AB cosine C. And that is the last part of the proof for law of cosines. Thanks for watching.